Hello and welcome back to Mr. Powers Teaches Algebra. We have been looking at sequences. We looked at, just all plain old sequences, arithmetic sequences, and then we looked at geometric sequences. And now we're going to look at series. So what is a series? And this video is just a quick little explanation of what a series is, just some definitions. So what is a series? It is the sum of terms in a sequence that usually follow a rule. So it's like you take in a sequence, and instead of just listing them out or finding the fifth term or eighth term, you're going to add them up. We're going to add up all the terms, or add up maybe the first term to the eighth term, the first term to the 23rd term, or maybe the 15th term to the 80th term. But we're just going to be adding them up. That's a series, okay? So here's some examples of series. Here's a finite series where we're adding a very simple arithmetic sequence. The counting numbers 1, 2, 3, 4, 5. So the first 5 counting numbers, we add them up. There's 5 terms. We get 15. I believe that's also known as a triangular number, aren't they? They are. Those are triangular numbers in case you didn't know. There's a reason they're called triangular. We may get into that later. And we got infinite series. So infinite series are series that end with an ellipse, where we're going to add all the terms forever and ever. And this is a fun example: a half plus a fourth plus an eighth plus a 16th, so on and so forth. And what do you get? Well, you get 1. Even though you go for infinitely long, it reaches an actual value. And those are really interesting. You get an infinite series that adds up to something. That's really cool. So we'll be looking at those. Of course, lots of times a series of add them up forever that's going to blow up to infinity or go all over the place. It depends. So an arithmetic series is the sum of the terms in an arithmetic sequence, like here up here. This is not arithmetic here. This would be geometric. Geometric series is the sum of terms in a geometric sequence. Here we're at multiplying by a half to get each term, times a half, times a half, times a half. Okay. So, moving on. If we have a sequence, say a sub n, and it is 3, 7, 11, 15, 19, right? And if I wanted to write this as in an explicit form, we could say it is -1 plus 4n. That would be our explicit formula for this sequence. I believe. Looks right. Okay. Because it's plus 4, plus 4, plus 4. Then we could have a corresponding series, S, and we like to use S kind of for the sum of a series, you'll notice. And that would be adding those terms up, in this case, infinitely. Of course, they're always getting bigger and bigger. This is going to approach infinity. We say it's approaching infinity because you can't really equal infinity, so it's approaching infinity. It blows up. It just diverges is another word we like to use. It's divergent. Whereas here, this one actually, adding up infinitely many terms, actually converges. It equals something. Okay? So the nth partial sum of a series is the sum of a finite number of consecutive terms beginning with the first term. Finite being, hey, there's a certain number of terms we're going to be adding, not an infinite number. The notation S sub n represents a partial sum. Okay, so in this case, S1 is just the first term. S2 is our first 2 terms added up. S3 would be the first 3 terms added up. N equals 1 to n equals 3, and so on. And I believe that's all I really want to go over in this video. It's just some really quick notation when we're talking about these things. And then the next thing we're going to be going over is this summation notation, a way to rewrite S4 kind of incorporating an explicit formula here would be with this summation notation. So that's coming up in the next video. So until next time, enjoy doing math.